Hi, everybody. Today we're going to review graphing linear inequalities. Okay, so um, what's linear inequality again? A linear inequality is an inequality of the form ax plus by is less than c, ax plus by is less than or equal to c, ax plus by is greater than c, or ax plus by is greater than or equal to c, where a and b are not both zero. Okay, one of them can be zero, but not both of them. Otherwise, you would have zero. You just have like zero is greater than or equal to -2 or something. So you wouldn't have an inequality, a linear inequality then. An ordered pair is a solution to the inequality if the inequality is true when that ordered pair is substituted into the inequality and it forms a true statement. So, for example, -212 is a solution to 5x plus y is less than 3, because if I substitute -2 in for x and I substitute 12 in for y, I get 5 times -2 plus 12. That's -10 right here, plus 12 is 2, which is less than 3, and that's a true statement. Okay, so that means that this is a solution then. Okay, if it was a false statement, if I got, say, the other way around, 3 is less than 2, then it would not be a solution to the linear inequality. Okay, so check whether the ordered pairs or solutions to 3x plus 2y is greater than 2. So very simple to do. You're just going to take the x and y and substitute them in. So this one would be 3 times 0 plus 2 times 0 would have to be greater than 2. And obviously this is 0 plus 0. 0 is not greater than 2, so it is not a solution. Okay. So we'll take these and make them fit here. Now what I want you to do is I want you to pause the video, do these 3, and then jump back on here and turn it back on and see how you did. Okay, so let's do this one. 3 times 2 plus 2 times -1 should be greater than 2. So that would be 6 minus 2 is greater than 2, and 4 is greater than 2. That's true, so that is a solution. Okay, so hopefully you got that one. Okay, now this one. 0, 1, 3 times 0 plus 2 times 1 is greater than 2. So that would be 0 plus 2 is greater than 2. 2 is greater than 2. Now, that, my friends, is not true. Okay, now, if this was greater than or equal to, it would be true, but it's not. So we would say that this is not a solution. Okay, last one. We're going to put this one down below here. So this would be 3 times 5 plus 2 times -6 should be greater than 2. That'd be 15. Minus 12 is greater than 2. 3 is greater than true. That is a solution. Okay, so we had 2 that were not solutions. We had 2 that were solutions. And we're done. Let's slide all these over a bit. And there we go. Okay, let's move on. Okay, you can tell if an ordered pair is a solution if the ordered pair falls in the solution region of the graph of the inequality. Okay, so, whoops, we have a mistake here, which we need to fix. Okay, so bear with me just a second. All right, so what happened here? So we've got this this inequality here. 3x plus 2y is greater than 2. So what I had graphed, when I had a solid line here that's greater than or equal to 2, it probably would have actually been easier to just put the greater than or equal to sign on there, which is probably what I meant in the first place. But in fact, you know what? Let's do that. And let's just do this. There we go. Okay, so what do we got here? We've graphed the line, okay? And since it's greater than or equal to, that means that we have a solid line here. When it was greater than, I would have a dotted line along here. And then we have shaded above the line, okay? So this is the region. Anything in the yellow here is where the solutions are, okay? So it's very simple. If I want to know if 0, 0 is a solution, so 0, 0 is right here. Oh, it's not in the shaded region, so it's not a solution. Okay, let's try 2, -1. Where does 2, -1 fall? 2, -1. Nope. Outside, also not a solution. Okay, let's look at, oops, we already did blue. How about 0, 1? 0, 1 would be right here. Nope, not a solution. Well, this is getting boring. And 5, -6. Okay, where would, let's do this. Let's color 5. 1, 2, 3, 4, 5, -6. 1, 2, 3, 4, 5, 6. Wow. Okay, also not a solution. Okay, what would be a solution? How about this point right here? 1, 2, 3, 4, 1, 2, 3, 4, 3 would be a solution to the equation. Okay, this point 9, -1 would be a solution. Anything in the shaded region, anything on the line, in fact, because it's greater than or equal to, so I could go right here and say, what is that? -2, 1, 2, 3, 4, 5, 6. -2, 6 is a solution. Okay, now if this was just greater than, and this would then be a dotted line instead of a solid line, anything on the line would not be a solution, but anything right next to the line on the upper side would be a solution. Okay. Sketch the graphs of the linear inequalities. So this one's a pretty easy one. Let's do this. Okay, it's greater than, y is greater than or equal to 3, so we go 1, 2, 3. We got a line right here. It's solid because it's greater than or equal to, and we want to shade the greater than side. So we're going to shade everything up here. Okay. Now, x is less than 2. Okay, so that'd be a vertical line at 2. Oops, it's got to be a dotted vertical line because it's just less than. Okay, so there we've got that. And now we want to shade this side over here because we want everything where the x is less than 2. Okay? So, piece of cake. All right, how about this one? -x plus y is less than 5. Okay, here's what I'm going to do with this. I would rather... oops, that's what I want. I would rather take this equation and add x to both sides and do this in slope-intercept form. So I've got a point, y-intercept is 5, 3, 4, 5 right there. The slope is 1, so this is going to go like this. And then I'm going to go ahead and make a line like that. Let's make it blue. line. Okay, oh, and it's dotted because it's less than. Okay, so there's my dotted line. I can kind of clean that up there a bit. Okay, so now I want to be less than that. So I got to be below the line. So I'm going to go ahead and get my highlighter, and I'm going to go ahead and shade anything below that line right there. Okay, there's my graph. Okay, the time in minutes that a scuba diver can remain at a depth d in feet without having to decompress while surfacing is given by the following inequalities. Okay, so if you don't understand what this means, when you're diving, you're underwater. Water is much heavier than air. It puts a lot more pressure on the outside of your body, okay? And so when you breathe oxygen out of a tank, that air is compressed, okay? Your body has to take that oxygen in and keep the pressure on the inside of you equal to the pressure on the outside of you. Otherwise, you get crushed, okay? So what happens is you build up pressure, air pressure in your veins and your lungs. And then if you come up out of that water, that has to come out. It's kind of like a bottle of soda, okay? When you just look at the bottle of soda before you've opened it, there's no bubbles in there. But you pop that top and all of a sudden, all those bubbles come up, okay? That's what would happen inside your in your veins. That's called getting the bends, and it's extremely dangerous. It's very painful, okay? So there's actually equations for how long you can be underwater and how deep you can be underwater for certain lengths of times before you have to decompress, okay? So for depths between 60 and 90 feet, if you're diving between 60 and 90 feet, the time has to be less than or equal to 120 minus the depth, okay? For depths between 90 and 130 feet, the time has to be less than or equal to 75 minus half the depth. So sketch the graph of these inequalities. So here, this graph was already done. Okay, so what you've got is 120 minus d. That would be this line right here. Okay, between 60 and 90 feet, and then between 90 and 130 feet, you've got that line there. Okay, if you're less than 60 feet, it goes up like this. You pretty much don't have to decompress. Okay, if you're more than 130 feet for any length of time, you're going to have to decompress. Okay, so basically what you do is you come up very slowly. Have you ever noticed if you blow a bubble underwater, as the bubble rises in the water, it gets bigger? That's because the pressure in the bubble is having less pressure on the outside as it's coming up, and so it's getting bigger. Okay, that's what would happen inside your body if you come up too quickly. Okay, so sketch the graph of these inequalities. Does a diver with a depth and time of 80, 50 need to decompress? So your depths would be 80 and your time would be 50. Okay, so you're going to fall in here. Okay, so it would say that 50 would be less than or equal to 120 minus 80. So 50 would be less than or equal to 40. Okay, so that is not a true statement. Okay, and if you look at the graph, 80 feet and you're under for 50 minutes, that would put you right here. Okay, so since this is not true, you must decompress. Decompression would be required. Okay, this is a dangerous situation for you. You do not want to be in that without decompressing. Okay, what about a diver with a depth time of 120? So your depth is 100 and your time is 20 minutes. That would locate you right there. Whoops. 120 would be right here. What happened there? Put this back. And then we'll put our red dot, 120 right there. Okay, so you are not required to have, because if I put that into the equation, okay, it would be 20 would be less than or equal to 75 minus 1/2 of d. D is 100. Okay, so 20 would be less than or equal to 75 minus 50. So 20 would be less than or equal to 25. And so you do not require decompression. Okay. Moving right along. All right, here's your assignment. Have a good time with that. I'll see you guys later.